Hi, I'm the little handyman. I've got a little hand. In this video, I'm going to be reviewing the parts of your drill driver. I'm going to talk about the different switches and settings on your portable drill, when you want to use a specific setting so you can avoid things like stripped screws and broken drill bits. And at the end, I'm going to review a few tips that will have you drilling like a pro. So let's start by reviewing the parts of your drill driver. There is the handle. You want to place your dominant hand on the handle so you can best control the drill when you're using it. You may notice that more expensive drills have more comfortable handles. My drill here has this ergonomic shape to it. It's also covered in a soft, grippy rubber material, so it's easier on my hand. And that same material is also here, the butt of the drill, because that's where you want to place your non-dominant hand when you're using the drill, if you can. Especially when drilling bigger holes or into harder material, you want to place both hands on the drill to keep control of it. And this here is the trigger. The more you squeeze it, the faster the motor spins. It's sort of like a gas pedal. And like a gas pedal, you shouldn't floor it the whole way. You can mess up by placing the drill or screw in a place you didn't want, scratching the surface of what you're drilling into, or cause some other damage. And above the trigger is the directional switch. Mine has these little arrows on it that say which way is which. There's forward or clockwise and backwards or counterclockwise. If you leave the switch in the middle, that will lock the drill. Best practice is to lock the drill when not in use. It is safer and it will keep you from wasting battery. My drill came with a soft carrying case, and every time I put the drill in the case without locking it first, something moves around and presses on the trigger. And this part here houses the motor. The motor needs to breathe, so don't put duct tape or anything else over the vents. And on top is the speed switch. Basic drills may not have this switch. Very expensive drills have 3 settings. This drill has 2. The higher the number, the higher the speed. But there's a trade-off. More speed means less torque. Basically, less power. The setting you want to use depends upon 3 things: the drill bit you're using, the material you're drilling into, and the size of the hole. If I'm drilling into drywall or plywood, those are relatively soft materials, so I'd leave the setting at a 2 because a faster speed is going to give me a cleaner hole. If I'm drilling into softwood, like a 2x4, or plastic, then I would leave the setting at a 2 for any drill bit up to a 1/4 inch. Your driver bits are a 1/4 inch, so if you can't tell what size your drill bit is, just compare it to your driver bits. If it's any bigger than that, I'll switch to the lower setting. For hardwood, like oak or maple, for metal, and for masonry, like brick, I'll leave the drill in the lowest speed setting. If I'm drilling in screws or bolts, then I usually just leave the drill in the lower speed setting unless it's something like a very long bolt that's finely threaded and I just want to speed up the process. There are charts out there that will tell you the precise rating for your material, drill bit type, and size of hole. But then you need to look up the RPMs for your specific drill. It's too much. I'm just telling you what I do because to me it's produced great results. I tend to err on the side of the lower setting. More speed means more friction, so the drill bit and the work material get hotter faster, and that can lead to problems like smoke and dull or broken drill bits. And this part here is the clutch or torque adjustment. There's a symbol here, which is the drill setting. The rest of the settings are numbered. The lower the number, the less torque the drill can exert before it cams out. Here's an example of that. So this is a very useful setting. If you allow the drill to exert too much torque, then you can drive the screw too deep into the wood, or you may strip out the screw. If you have the setting too low, then the screw won't go all the way in. How much torque you need depends upon 3 things: how hard the material you're working with is, how wide your screw is, and how deep you want to drive that screw into the material. Little tiny screws into plywood, probably start at a 1. A 3-inch long screw into oak, then you should start at a higher setting. Rather than memorize which settings apply to which situations, just set lower than you think is right, and you can ratchet it up from there if it's not enough. However, you make this all a lot harder on yourself if you don't pre-drill your holes. Always pre-drill your holes. This is a drill and a driver. Use it for both. We get to the end of your drill. This part here is the chuck. You twist it by hand to tighten or loosen this part here, the collet. Inside the collet are 3 jaws. These jaws grip down onto your drill bit. Typically, the jaws can hold a drill bit up to 1/2 inch in diameter. When you want to change drill bits, simply loosen the chuck to remove the old drill bit. Then loosen or tighten the chuck so that it's slightly larger than your new drill bit. Place the bit inside the collet and then tighten the chuck until it clicks. Make sure your bit is being held by all 3 jaws. This will keep the bit centered and straight. You can sometimes get a bit stuck between only 2 of the jaws. This will be obvious because when you run the drill, the bit will go in loops instead of twists. To drill a hole, simply place the appropriately sized bit in the chuck. Make sure the settings match the situation. Line up your bit with where you want to drill a hole. Keep both hands on the drill if possible, and let the drill do the work. To drive a screw, simply change out the drill bit for the appropriate driver bit. Change the settings for driving a screw, then place your screw in the pre-drilled hole. If you give the screw a little twist, that can help it stay in the hole. Place the driver in the screw head, and then with both hands on the drill, drive in the screw. Start slow and end slow for best results. If the drill is slow or weak or not moving at all, most likely you just need to charge the battery. Simply pop the battery out of the drill and place it on the charger for an hour or 2. Don't leave a charged battery on the charger. That shortens the life of the battery. Now for my 6 tips to have you drilling like a pro. Number 1, wear proper safety equipment. The pros wear safety glasses and hearing protection, and so should you. I can drill all day and be fine, but the neighbors are going deaf. Number 2, always pre-drill your holes. If you don't pre-drill, you can split or crack your material, and screws hold stronger in pre-drilled holes. All that material that is where the screw ends up has to go somewhere. So even if it doesn't split, it'll be compressed, which makes for a weaker hold. So always pre-drill your holes. Number 3, clear the waste. Don't try to drill every hole in one shot. If I'm drilling a hole deeper than say an inch, I always back my drill bit out a few times so I can clear the crud out of the drill bit on my way down. This makes it easier for the drill bit to do its job and keeps things cooler. Number 4, start small. When I have to drill a bigger hole, I usually start by drilling a small starter hole first. This will guide the bigger drill bit, which is more prone to walk away from where I want it and is a lot more obvious when it's not straight. Number 5, a sacrificial board prevents exit wounds. Drilling through wood can leave a messy hole on the exit side of the board because of the wood grain. Just clamp a small sacrificial board to the back of your work material. That will support the wood fibers surrounding the hole and keep it clean. In a pinch, some masking or painter's tape can also be effective. Number 6, use lube. That's right, my last tip is to use lubricant. A little WD-40 can keep a drill bit cool and cutting smoothly, and is absolutely necessary when drilling through steel. But be careful, because grease or oil can stain raw wood. Also, a little WD-40 or paste wax will help a screw slide in with ease. If you can hear the screw making a noise as it's going in, it needs a little lubricant. So thanks guys for watching all the way through. Be sure to like and subscribe to help us grow the channel, and also leave a comment below. I do my best to answer your questions, and I appreciate all of your feedback. And so until next time, get it done the right way.